Hi, Jim Berthold here from OLI Systems. Today's tutorial, we're going to go through looking at the OLI Chemistry Wizard that's used with Aspen Plus. A question that has come up frequently is, how do I modify the chemistry to reduce the size of the model? We'll have some caveats in a little bit, but we're going to go ahead and give it a shot now. We're going to go ahead and open up an existing model that we have created, just so we can speed up the discussion. This will be in the mixed solvent electrolyte model, but it doesn't matter for this discussion. And we have a very simple model. We have water, iron 3 chloride, and nitric acid. So if you've used Aspen Plus before with OLI, you know that we have to crank through these steps here, which I'm going to do so very quickly. There's nothing new here. And we're going to create a backup file that we're using with the software. I've already created this backup file, which I want to use later, so I'm just going to give this a temporary name. This is actually good practice if you need to modify chemistry for an existing process, that you don't accidentally overwrite the process name. We'll actually give you a warning message to let you know that there is an existing BKP file. Again, that's actually not part of the story today, but we're going to go ahead and do that, and we're just going to go ahead and let it generate all the files necessary. This will take several seconds to process the data, and then it will finish. After a moment, it tells you where we've got the file stored, and we're ready. We can actually go ahead and shut down the program at this point. We're now going to have a file that's got the BKP file or the APW file. Okay, I've already pre-run this, so we're going to launch the APW file to show you the problem here with these too many species. I'm going to right click and select open with Aspen Plus version 12, and we'll see that in a moment. Okay, after a few minutes, the process will come up. Again, we've already run this case here. It's just a single stream into a two-phase separator. Okay, the separator is being run at adiabatic conditions, so really we're interested only in the inlet stream here. So the input, just to let you know what we did, okay, is very simple. It is a stream at 25 degrees and 1 atmosphere, and we have 55.508 moles of water. This is approximately a kilogram of water, 1 mole of nitric acid, and 0.01 moles of iron 3 chloride. I used a very small number here just to illustrate the point. Now the process has already been run, so I have results. So I'm going to go ahead and look at the results stream. And this is, common to all things. I'm going to actually look at mole fractions here, and it comes down, and you start looking at very, very small numbers here. 10 to the minus 12th, those are troubling, but not horribly. 10 to the minus 17th and 10 to the minus 18th on a mole fraction basis, they're definitely getting small. But in this particular set of chemistries, we actually have numbers that are very, very small. And here is a mole fraction of 10 to the minus 27th. Now, from a pure thermodynamic point of view, we need to keep all of these species here to make sure that we have constant paths of all the thermodynamic parameters from every input species through every output species. If I didn't have it, I could have a disconnect. However, let's talk about some reality here. What this means is that I have, well, if you believe in Avogadro's number, which is 10 to the plus 23 moles, atoms per mole, this is telling me I'm about a few thousandths of a molecule less than a molecule. So that means it can't be physically real, but statistically it is. But we're interested in this component. This is the FeO2 minus 1 ion, and we can remove it from our model with some heroics. There's another reason why you want to remove some things from your model. Now, we have all of these solids that are present here. I could have taken them off as well. I didn't in this particular case. But if you have a lot of these tiny species, and there could be hundreds of them in your model, it turns out this screen takes a long time to load. Aspen Plus actually rebuilds the screen species by species. So if you have 300 species in this list, it can take a very long time to load. So what we're going to do just for this example is I'm going to take this species, the FeO2-1 species, and remove it from the OLI chemistry model as an example of how to remove species. And we'll do that in the very next section. We're going to relaunch the OLI Chemistry Wizard with a new model, same composition, and we'll show you what to do. Okay, we've shut down Aspen Plus, which is a requirement for this step, and we've opened up the OLI Chemistry Wizard again. I'm putting in a new model name. By the way, TMS stands for too many species. That's all that means. And I'm going to go ahead and create the chemistry, once again, using the MSC model. And we'll add in our components of HNO3 and iron 3 chloride. Exactly the same chemistry we had before. I'm then going to go ahead and generate the model, partially. All of these steps should be familiar to you if you've used Chemistry Wizard before with OLI. Okay, this is the step where we are creating the Aspen names. Okay, the species that we're going to be targeting is this Fe2-1 species. This is the OLI name, Fe, 3 I's for the ferric ion, O2 ion, and we have to remember that name. We're then going to go over to this screen. We're going to create the new BKP file. I don't have to create a new one because it doesn't exist. And we're going to come up on this screen. We're going to stop here at this point. Don't close the screen. Don't do anything else. We need to go over to our file management system. Okay. We've created a file here called tmsred.mod. And that is actually being created by this program, the Chemistry Wizard. I need to manually edit this file. I use a program called Notepad++, but you can use any text editor you want. It'll take a second to launch it because I have a lot of programs running. So there is Notepad++. It is launched temporarily into another window. And here it is. So this is a very, very old way of looking at our model files. I'm actually going to be looking for that species, which I pointed out before, of an ion called FeIIIO2 ion. That's this guy here I've highlighted. And I'm going to put a semicolon in front of it. A semicolon acts as a comment. You can see I've got a couple others here too. The OLI software will see the comment line and ignore everything to the right of it. And here's a part that's very, very important. If I remove a species, I must also remove an equation. Okay? And that will be an equilibrium equation. So I'm going to look for exactly the same species, FeIIIO2 ion, down in the equation set. And that's this guy here. I'm also going to comment it out. Okay. So the rule is one species, one equation. They have to be, the numbers have to match. So if I remove one up here, like I did with this semicolon, I have to remove it down here as well. That keeps the internal count correct. Okay. All I'm going to do now is physically save that file. No name change or anything. I will close Notepad. Come back to Chemistry Wizard. It now does not know that file has changed, and I'm going to click Generate Files Now. Okay. It goes through and creates the rest of our files in this folder. Okay. And it will give me a message here that lets me know it's done, and then I can move on. When I've done that, I'll just click the Finish button, and we can do the rest of our work. And there it is. I'm going to go now and create the same process file I created before using the new one. You can see there's a new BKP file here. I'm going to use Aspen Plus version 12 again. Although any of these versions work, you can see I have 10 and 11 also installed. And we will go ahead and launch Aspen Plus, create the file, and then we'll take a look at the results. So now we've created the file and edited everything together. Everything is exactly the same, and I'm just going to look at the results of stream 1, just like we did before. It's all the same, except I'm now missing that component. Okay, so down, here we go, again, down to mole fractions. We'll scroll on down. Things at the top here didn't change so much, but if we're looking for that species, that FeO2 minus 1, you'll see that it's not here. Okay, we've actually mathematically eliminated it from the model. We could go back and do it all at one time. I wouldn't do it individually, and start looking at these other least likely species, and so forth. And you may want to remove them as well. They're small on concentration. They will definitely speed up the program, and they will make this refresh of this stream results page much faster if you do that. However, you do run the risk of creating an error or thermodynamic inconsistencies, so be careful. Remember, though, if you remove a species, you must also remove its corresponding equation and things you should never remove. You should never remove what I call a bare ion, such as a chloride ion. It's hydroxide ion. If you looked at the top of this screen here, there is a hydroxide ion. It's pretty small. Don't remove that. Okay, that goes into the water equation. All kinds of bad things happen if you get rid of that. So the only things you're really a target are things that are complexes, things that are more than one element, and are not a bare ion, such as a nitrate. Keep those guys still in the model and just remove these things. What I like to do is I like to print out the model. You saw there was a page there. It's Notepad or Notepad++. You can print it out and actually start annotating it, so to make sure that you remove one species and one equation with the same species every time you do it. It can be complicated, so be careful. This is actually an unsupported feature for OLI systems, so we will not support you in real time on this. We recommend that you don't do this, but if you do this, you can send us an email and I'll support you as best I can, but these will take lower priority than other things that are fully supported. Thank you for your attention. If you have any questions about the video, please, of course, let me know. Thank you.